Alright, so in this video, we're going to be reviewing acids and bases. This is a little bit of review of what we did in class today, and it is also a little bit of foreshadowing for what we're doing in class tomorrow. So today we talked about two different theories of bases, alright? One of these theories was focusing on concentration. The other theory was focusing on our movement of our hydrogen, which is also known as the movement of our proton. All right? So in our Arrhenius theory, we're looking at concentration. So for a base, our Arrhenius theory is telling us that a base increases the OH concentration. So what's really happening here, according to this theory, is you have a base going in that is part one element, part a hydroxyl group, all right, or an OH group, an hydroxide group. So that's going to split apart into the sodium and the hydroxide. So when it goes in, it's going to split apart, and we're going to have an increase in this hydroxide group. Now, on the other hand, an acid increases our H plus concentration, or our hydrogen concentration. So in that case, we might have something like HCl, where we have hydrogen and chloride, and that would break apart into H and Cl once it goes into our solution. So in the solution, it's adding this H plus concentration. Now we can measure H plus, or the amount of H plus, using something called a pH scale. All right? pH scale. What that is standing for is a mathematical term called the log of H. This is something you might have heard about in trigonometry before. If you haven't heard about it, we'll talk about it more in class tomorrow. But the idea is that pH is measuring the changes in my H concentration. So the more H I have, the lower my numbers are actually going to go. So in this case, the most acidic is going to be 0 or 1. And that's thinking about my H concentration. All right? Now, on the other hand, the less H I have, the higher my number is going to go. I know it seems a little backwards. It's something we'll work with in class. But the lower my H is going to go. So a very basic solution is something like bleach, which has a pH of about 13. In the middle, neutral, is like our distilled water. Our drinking water, we want to have a neutral pH. Then down here, something like stomach acid, that is very acidic. It's acidic so it can break apart the food in your stomach. All right? So we have this whole spectrum, and this is describing our H plus concentration. All right? Now, the other theory that we talked about in class today was looking more at protons. And specifically, those protons were the movement of our hydrogen. So in this case, we have two differentiations here. A base is differentiated by being a proton acceptor, while an acid is differentiated by being a proton donator. That means in this case that this proton, hydrogen, would be donated from our acid to our base, which in this case could just be our water, because our water would accept that proton. All right? So we got acceptors, which are our base, donators, which are our acid. Again, we can measure how basic or acidic something is by using our scale. And all of these solutions are things that you interact with probably on a daily basis. For example, black coffee is slightly acidic at 5, whereas lemon juice is very acidic at 2. Up here we have soapy water is pretty basic at 12, while baking soda is more moderately basic at 9. This whole scale tells us how basic or acidic something is. Tomorrow in class, we'll be focusing more on what it means to have a different pH, and also looking to see how pH is calculated.